All right, the day you've all been waiting for, finding the variance and standard deviation of discrete probability distributions. Away we go. All right, so here's an example. It says, suppose a classroom is randomly selected at a state university. Researchers want to determine the probability that the student is taking exactly 4 classes. The data collected created the following discrete probability distribution. So, obviously I just found this on the internets, but I like to see things in a vertical table, so that's what I'm going to do right now. So I'm going to redraw this, and this is how I would recommend always doing it. X in this case is going to be the number of classes. And then remember, P of X is the probability that happened. Also, if you hear banging, it's because they're building a garage literally right next door to where I am. Okay, so the probability that somebody was taking 3 classes is 3 out of 23. I'm going to make these into decimals so we can work with them easier. So this is 0.13. This is 0.17. Oh, no. I'm lying. 3 out of 23 is 0.13. I need 8 out of 23. 0.35. Then 9 out of 23 is 0.39. And then 3 out of 23 again was 0.13. Remember, this is a probability distribution, so all of those numbers should equal 1. I'm just going to check real quick. I did round some of the numbers, so it might be off. Let's cross our fingers. No, it equals 1. So it does equal 1. Okay? Now, last week we talked about getting the expected value. And the expected value, remember, was just the same thing as the average. And that was the E of X. Remember, to get the expected value, you do this times this. Oh, I'm doing these quick. This is 39. Just kidding. And then this is 0.78. Okay, so your expected value was the sum of this entire column. Remember, that's the symbol for summation. So I'm going to add up all these numbers. And we're going to try to keep these problems pretty short because we do have to do them by hand. There is a shortcut on the calculator. So 4.52, you do need this number. So the average number of classes that a student is taking is 4.5. And I know that last week we did talk about like partials of the answer. You're going to leave it as 4.52. That is the actual average number of classes that a person is taking, okay? Now, in order to find the variance is related to the standard deviation. You should remember standard deviation from our bell curve. So let's say, whatever, the average number of, I don't know, the average number of potato chips that you've eaten in one day of quarantine is 12, with a standard deviation of 8. So that means, remember, you travel 8 away each time when you're making, this obviously wouldn't exist, but you travel 8 away each time when you're making your bell curve. So all of this relates back to that bell curve. Remember, there was that 68 rule, 68, 97, 99.5. So this is all relating back to that. Okay, so what we're going to do now is figure out what the standard deviation is for this problem. And here's the formula. In order to find the standard deviation, you first have to find the variance. The variance is going to be the distance that each of these numbers is away from the mean. And the standard deviation is how far away they are from each other. Okay, so it's a very easy formula. Here it is. It is the summation of x squared times p of x minus mu squared. Just real simple. And the variance is really normally written as that. Remember, that's your lowercase sigma. Okay. Do not stop watching the video because I'm going to make it very easy for you. You actually don't need this column right this second, but you do need to remember that this is the average. Remember, the average is just another way of writing mu. So when we do this, we need the 4.52 to replace this symbol here. Okay? In order to calculate the variance, it's very easy actually. You first go to your x column. Whatever the numbers are here, you square them. So this would be 9, 16, 25, 36. Okay. Then in this column, I'm going to put this answer. So this set of parentheses is going to go here. Inside this set of parentheses, it literally just tells you to take x squared, which you just got, times p of x. And you already have a column called p of x. That was a bad choice. You already have a column called p of x. So all you're going to do in this column is do 9 times 0.13. The next one would be 16 times 0.35. You're just following a formula. 25 times 0.39. 36 times 0.13. And then the formula says, so we squared something, we multiplied the probability times the square, and then the formula says to sum it all up. So I'm going to add up this entire column. And if you do this carefully in the calculator, you can literally just put in the calculator 9 times 0.13 plus 16 times 0.35 plus 25 times 0.39 plus 36 times 0.13. So if you put all of that in the calculator, that will tell you what the summation is. So when you do that, you should get 21.2. Yep, 21.2. Okay, so now the formula says to take this number, that was the answer for all of this, and take away the average squared. So here's the average. So first let me do this. 21.2 minus 4.5 squared. And you get 0.95. Okay, so that's your variance. That's sigma squared. So the variance is telling you how many places each one of these is away from the average. Okay? Your standard deviation is really what we should worry about. And the standard deviation is just the square root of 0.95, which is 0.974, so 0.97. Okay, so what this means is that if you were going to draw a bell curve, the average number of classes a student is taking is 4.52. Each one of these is going to increase by 0.97 every time. and so on. Okay. I'll do one more problem from the worksheet, and then whatever is left, I'm just going to leave you guys to do. It looks very complicated. It kind of is, but it really isn't. Okay. These are the problems from Friday. So let's just do these. We'll do this one about the transistors. Okay. So the good news is we already got on Friday the averages. So all you need to do in this case is take your x values and square them. So here was our original table from Friday. It was how many transistors there were. So 0, 1, 2, 3. And then it told us the probabilities. 0.92, 0.03, 0.03, 0.02. Okay, so first I'm going to square the number of transistors. 0, 1, 4, 9. Great. Then I'm going to multiply x squared times its probability. So 0.03, 4 times 0.03, obviously 0.12, and then 9 times 0.02 is 0.18. Just check. Yeah. Okay. So now this is x squared p of x. Add all of these up. It's 0.33. And here we go. The sum of all of this was 0.33 minus the average squared. This is the average that came from the answer on Friday. If you didn't do this on Friday, that's how we got the answer. So 0.33 minus 0.15 squared is 0.3075. Then to get the standard deviation, which is the main point of this entire thing, you just take the square root of 0.3055 and you get 0.5545, so 0.55. So the average was 0.55 and it's going to increase and decrease in increments of 0.55. Okay. The questions that are left, I'm going to leave for you to do on the go formative. And you know what, maybe I'll just have you do like 2 questions because it's kind of a long process. And if you can do 2 questions, I think you can do it for all of the other questions. All right, so I will put this up on Go Formative, finish whatever questions I put there for you. And if you have questions, please let me know.